This episode, integration by parts and DI method, coming up, back interaction. Hey guys, today I will show you how to integrate functions using integration by parts formula more than once. Yeah, sometimes you have to use it more than one time. Also, at the very end, I will show you DI method, which is basically a shortcut for integrating expressions. Let's just do it. Suppose you are given that integral x cubed e to the x dx. There is a pattern, there is a formula to be used. And you always start off with picking your u expression. As a good rule of thumb, if you are given algebraic expression and it appears in your integral, like here we have x cubed, most of the time, certainly it's gonna be your u expression. And if you need, by the way, help with picking your u expression, you could check out my first episode, Integration by Parts, where I explained and I came up with a mnemonic device, mnemonic trick, how to pick your u expression. Check it out later. So in this case, x cubed is gonna be your u expression. Automatically, what's left over, including dx, it's gonna be your dv. So e to the x dx, it's gonna be your dv expression. Now, let's write it off to the side. So we define your u to be is x cubed, and your dv is e to the x dx. Now, in order to apply this formula, we need to know also v and du. So, since we define u to be x cubed, we can find du. So, your du, and all you need to do to find du is just take the derivative of x cubed. So differentiate x cubed with respect to x. So since this is a power, so the derivative of x cubed is just 3x squared. And at this point, you have to attach dx, since this is differential. So 3x squared dx. So this is your du. Now, also we need to know v. And to find v, all we need to do is just take the integral of e to the x dx. And since the entire derivative of e to the x is just e to the x, so v is e to the x. So this is v. And notice at this point we don't need to add the arbitrary constant of integration c as we would normally do for normal integration, since it wouldn't matter at the end. Now, let's get back to the integral. In the next line, equals. Now, we're going to apply this formula. And this formula says u times v. So this is your u, which is x cubed, gets multiplied by v. So your v is e to the x. Minus, subtract off, the integral v du. So uv is e to the x times, and udu is 3x squared dx. All right. Look at this integral and ask yourself, can we integrate it? Can we take this integral right off the bat immediately? No, unfortunately, because it looks similar. It's kind of reminiscent what we had before. Again, we have two functions being multiplied. Well, to be perfectly frank with you, sometimes at this point your integral is solvable, it's integrable, so you can take it, and at this point you are lucky one. In this case, no, we cannot. But what we can do is, surprise, surprise, apply integration by parts formula again, second time. Let's do it. So again, it comes down to picking your u expression. And again, as a rule of thumb, 3x squared, that's algebraic expression that appears in your problem. So it's gonna be your u. So again, if you are given algebraic expression, so something like involving x, it could be x squared, any power of x, so anything involving x. If it appears in your integral, it's certainly gonna be your u expression. Now, what's left over, including dx, namely ex dx, this is your dv. And let's write it off to the side. So we set your u being 3x squared, and your dv is e to the x dx. Notice that dv is precisely the same what we had before, so it's perfectly fine. And since it's the same, uv is gonna be just e to the x, and we are done with v. Now let's find du. So du it's gonna be, so we need to differentiate this expression with respect to x, take the derivative. So becomes just 6x, and we need to attach this dx at the very end since this is differential. Now next line of your work. So notice that we already have this chunk, and this is already a part of your solution. So at this point just carry it down, drop it down. So x cubed e to the x minus, subtract off, and I would suggest you to draw the parentheses for this integral since you have this negative out front, and this negative has to be applied and distributes to all terms inside of your parentheses. So it's a good policy, it's better to say than sorry to write this negative out front, because all your terms after, when we remove the parentheses, the sign in front has to be switched, has to be flipped. So now we're going to apply this formula. So u times v. So your u is 3x squared and your v is e to the x. So 3x squared times e to the x minus, subtract off the integral v du. So your v is e to the x and your du is this 6x dx. Again, look at this integral. So again, we cannot integrate it right off the bat immediately, since it's not a table integral. So again, at this point we have to apply again integration by parts formula or uv formula. Well, let me just clean it up a little bit and open up the parentheses since it looks a little bit bulky. So again, at this point, these two chunks, these two pieces, they're already a part of your solution. So carry it on. Just drop it down, carry it down. So minus 3x squared e to the x. And since you have negative in front of the parentheses, so this negative applies and distributes to both terms inside. So this integral becomes positive overall, so plus. Now, again, it comes to selecting to picking your u, and your u is gonna be 6x. So this is your u, and the rest goes for dv. So e to the x dx, that's your dv expression. And let's write it off to the side. So again, we set your u expression to be 6x. And let me find u immediately right off the bat. It's just 6 dx. Since the derivative of x is just 1, x disappeared, x drops out, x goes away, and dv is same story. dv is your e to the x dx, and uv is just e to the x. The same old story. Now, at this point, we are going to apply this formula. I'm going to draw a square parenthesis, kind of emphasize it. It's not necessary. You could draw a normal parenthesis brackets. So I'm just wanted to write the square brackets to just emphasize this integral. So what goes inside? U times v. So uu is 6x, uv is e to the x. So 6x times e to the x minus the integral v du. So v du. So it's gonna be e to the x times 6 dx. And good Lord. Look at this integral. So at this point, it's solvable. It's a table integral. It's just e to the x that basically we've already integrated so many times. So since 6 it's a constant and 6 has to be pulled out front, so you would have just the integral of e to the x dx. So, and it's solvable, it's integrable, it's a table integral. Congratulations, thank God we did it. Let's just clean it up. Let's just slick it up. So carry down these chunks. It's already part of your solution. So remove the parentheses at this point, distribute it. Minus, so as I said, 6 is a constant and 6 has to be pulled out front and place it out front of your integral. So 6 basically gets multiplied by the integral of e to the x to dx. dx is e to the x. And at this point, you have to add your best friend, the arbitrary constant of integration. Since this is indefinite integral, there is no limits, it's entire derivative, it's a general solution. And finally, we arrived at your final solution, the final integral. Alright, so this is your final general integral, final general solution for that integral. Well, as I mentioned before, there is a shortcut which is called a DI method, and I'm going to show you how to apply it for this integral. Coming up, stay tuned. Now, there is a shortcut that gives you instantaneous solution for this integral. It's rapid, it's fast. And I have another episode on a DI method, and you could check out on my playlist for integration. Now, the idea is you're going to construct and make up a table with two columns. The first one, it's called D, which stands for differentiation. And the second column is called I, which stands for integration. Now, in your first column, which is D, you are going to pick a function which is easier to differentiate. So, because over here we are going to differentiate. Whereas, for the second column, we are going to integrate I. Now, our goal, our aim is always to get 0 at the very end. As soon as we get 0, so we're going to differentiate repeatedly a few times. As soon as we get 0 over here, we stop, and I will show you how to get the final integral, the final solution. Now, if you look at your integral, at your functions, x cubed would be easier to differentiate a few times, and eventually we would come up with the 0. Since the derivative of e to the x is e to the x, and whatever times you differentiate e to the x, you would always end up with e to the x. So x cubed, it's gonna be your function for this D column. Also, if you notice that basically it's your U expression for the integration by parts formula, what we picked for U. So whatever you picked for U basically goes for your D column as a good rule of thumb. So e to the x, it's going to be your function, your factor for the second column. Now, we're going to differentiate x cubed. So the derivative of x cubed in its power is just 3x squared. Now, we're going to differentiate it another time. The derivative of 3x squared is just 6x. Next step, the derivative of 6x is just 6. So x goes away, x drops out. And finally, the last step, thankfully, the derivative of 6 is just 0, since 6 is a constant. Done. Stop now. So, as I mentioned before, as soon as we get 0, we stop. So a little bit disclaimer, sometimes it's impossible, sometimes you cannot get 0. So you would try other techniques, or you could just come up with applying integration by part formula straight up to this point. So there is no choice. Or you could just tweak your DI method a little bit over here. And this is another story, this is coming up. Now, let's complete the second column. So the integral, the entire derivative of e to the x, it's e to the x, stays the same. And we're going to repeat. So the integral of e to the x is e to the x. So we're going to integrate, so it's going to be the same. Nothing special. Now, on the very left side of your table, this tabular method, you are going to place the signs plus and minus. You always start with positive, and you are going to alternate. You are going between plus and minus. So this second row goes with minus, third row plus, minus, plus, and so on. If you have more rows, you are going to continue with alternating plus and minus. Now, we're almost there. We're going to take the first term from your first column, which is D, and you are going to take this term. You're going to use kind of diagonal. So this term, second row and second column. Now, same goes for second term for the first column and third term for the second column. Again, diagonal. This term and this term, these two and these two. And we're going to just multiply them. Multiply these diagonals, diagonally, like across, and they're going with these signs plus or minus according in regard to the row, and we're ready to write out the final answer, the final integral. So it becomes again x cubed times e to the x, and you take it with plus, positive. So just x cubed e to the x, your first term for your final integral. Next, 3x squared times e to the x, and it goes with negative, so minus 3x squared e to the x. Next term, 6x times e to the x, and it comes positive. So plus, let me drop it down, 6x e to the x. And finally the last term, 6 times e to the x, and it comes negative. So minus 6e to the x. And your best friend c goes at the very end. Since it's indefinite integral, and this is your final antiderivative or general solution, general integral for this problem. Well, it was expected, since we already integrated by using the integration by part formula, but as you see, it faster, it saves you time, and you don't need to use the integration by parts 3 times here actually. But as I said before, little disclaimer, so it doesn't work for all cases and all integrals in the world. So you can use it, but it depends. It depends on what are you given. Anyway, I hope it was helpful. Thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new videos.